Lesson 20, section 7.2, we're looking at the law of cosines. In the last section, we talked about solving triangles, and again, remember solving triangles is solving for all the sides and all the angles. Now we're going to use a new law. Before we had the law of sines, and if you recall, that was specifically this right here, okay? On the front of your notes, you now also have the law of cosines. Okay, these laws can be applied regardless of the angles that we have. Okay, so what we're going to do here is we're going to notice the comparison of these laws. Okay, I want you to look very closely at this. Notice the side squared is equal to one of the other sides squared plus one of the other sides squared. This should be a 2. I don't know why it's a C. Okay. Minus 2 times those two sides, cosine of the side that's supposed to be equal to in terms of the angle. Okay, so again, it's easy to memorize this. Side squared is equal to the other two sides squared added together minus 2 times those two sides again, cosine of the angle, okay, opposite that side. Now, the first example, okay, we're going to look at here is this one right here, and that's number 3A, okay. I wrote down all the information that we were given, okay, in this pattern. Notice we do not have an angle across from a side. We're given this side, and we don't know what this angle is, and we don't know what this angle is, okay, and we don't know what the side is. If I'm given a situation like this, okay, specifically being side, angle, side, okay, then I'm going to use law of cosines. Now, what formula am I going to use? Well, I might as well find this missing side. So b squared, and again, watch how I do this. B squared is equal to the other two sides squared minus 2 times the other two sides times the cosine of the angle that corresponds to the side. Okay, that's the formula. And again, all I'm going to do is plug this stuff in and find out what b is. So b is going to be equal to the square root of all this junk, plus or minus. But notice, it's a side length, so it's only plus, okay? A squared is going to be 100 plus 15 squared, I don't know off the top of my head, I don't remember math. 15 squared is 225, okay? Minus 2 times those two multiplied together, which is 150, times the cosine of 110 degrees, okay? Now, I'm going to go ahead and do all this math. Grab my calculator for the cosine of 110 degrees because that's not one of those nice ones that we know. So I'm going to have to type this into the calculator. Okay, we can do all the basic math, the 100 plus 225 in the calculator, the 150 times 2. But honestly, we might as well just go ahead and type it all into the calculator right off the bat. So if you can see this on mine, okay, I'm going to type in exactly what I see here. Again, right here, I'm going to type exactly what I see in here. I'm going to do the 100 plus 225 minus, it's going to be 300 times, again, my calculus is a little bit different, but I got cosine of 110 and second for that for my degree symbol. Make sure it's in degrees, okay. I'm going to hit enter. Sorry, mine's missing a parenthesis. Let's do that one more time. And making sure that all this stuff is exactly the same. Okay. I'm going to make sure it approximates it. And that's approximately 427. Now, this is the numerical value of this. Okay, the numerical value of this based on it equaling to b squared. Again, notice I used b equals to the square root stuff. I didn't take the square root yet, so I'm going to go ahead and do that. I'm going to do second square root of that numerical value. And I get approximately 20.67, 863735 dot 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 blah blah blah. Okay. Where do I round that to? Well, as in all of these problems, okay, you are going to round the side lengths to the number of decimal places given, or if the problem tells you to round to a certain decimal place, you will round to that decimal place. This just says find the missing side length of the triangle. This says find the missing side length. B is what I'm trying to find. It's going to be rounded to 1 decimal place, so it's going to be approximately, because it's rounded, 20.7. Okay, and that's what I was looking for. Okay, we're going to go ahead and do number 4 as well. Now 4A, on the other hand, says given this information, find the given angle. Okay, so it gave me A is 32 feet. Okay, B is 20 feet. C is 40 feet, and it wants me to find B. Okay, now I wrote it all over here, gave me all this information, and told me to find B. Well, which thing would I be using here? Well, if I'm trying to find B, I'm going to use the law of cosines one that contains the B as the angle. Okay, so let's go ahead and do that. It's actually the same one I have written right here. So I'm going to plug everything in. Okay, I have 20 squared is equal to 32 squared plus 40 squared minus 2 times the 32 times the 40 times the cosine of B. Now, you don't see it. Let me go ahead and scroll down here so you can see it. B squared, A squared, plus C squared minus 2 times A times C cosine of B. Okay. I'm going to go ahead and solve this thing for the cosine of B. Okay, so very carefully I'm going to get the cosine of B, and I'm going to be too lazy to evaluate all these numbers while I'm doing it. I will do it after the fact. This is going to be 20 squared minus 32 squared minus 40 squared, all divided by a negative 2 times the 32 times the 40. Okay. Again, mathematically, I subtract this to this side, subtract this to this side. That's where the negatives come from there. And I divide by this negative thing. Okay. In your textbook, you will actually notice that they do write out the formulas for the cosine of B. Okay. I'm just not doing that. Okay. Now, in my calculator, I'm going to go ahead and evaluate these. 20 squared minus 32 squared minus 40 squared. That numerical value divided by a negative 2 times 32 times 40, okay, gives me approximately, or I'm sorry, exactly the numerical value of 444. I'm sorry, this is wrong. Let me go back through and change that. It gives me the value of cosine of B is equal to a negative 139 divided by 400. Okay. Again, plugging that all into my calculator gives me this number. So I was looking for B. Well, what's B going to be? Is this a number that I know on the unit circle? No. Okay, if it was, I could use the unit circle, but it's not. So what I'm going to do instead is I'm going to say the cosine inverse of that number. Now, can I actually do this? Well, yeah. Negative 139 divided by 400 is something less than 1. If it's less than 1, then the cosine inverse can take that number in. And in my calculator, I'm going to make sure my mode is on degrees, okay, because otherwise the values that I get back won't make any sense. Again, I'm going to make sure my mode is on degrees, and in my calculator I'm going to type in cosine inverse of a negative 139 divided by the 400. Again, you'll see it right here. I'm going to type in this exact thing. I'm going to hit enter. My calculator likes to do things screwy, and I'm going to make sure my mode is in degree, and it is not. For me, it's in radian. I'm going to change it to degree, and then we're going to try this one more time. 110 degrees, 0.334. Now, how do I find out what this is? Well, it says me, given the information, find the given angle. It doesn't tell me what to round to. If it doesn't tell me what to round to, okay, so there's 3 stipulations here. Number 1, you round to the number of decimal places given for the situation. Number 2, if it tells you to round to that instead. Okay. The last stipulation, if it doesn't tell you to round to anything, and I don't have a measure, okay, like find B, it doesn't tell me any corresponding angles to measure to round to, I'm going to round to the nearest degree for this. So this is approximately, okay, this is approximately 110 degrees. Okay. That finishes problem 4A. We do have the time. I'm going to actually go ahead and run through 5, okay? For number 5, it says, when should we use law of sines and when should we use law of cosines? Okay, well, I'm going to draw some triangles here, and I'm going to go ahead and put A, B, C, little a, little b, little c, okay? And it says, when should we use them? When I have angle, side, angle. So if I have these 3 pieces right here, what should I use with these three pieces? Well, first off, if I have two angles, okay, it doesn't even matter what I have. If I have two angles, I can find the third. Finding the third angle will always allow me to use law of sines, okay? So for A, right here, it's obviously going to be law of sines, okay? So angle, side, angle is law of sines. This is after finding the missing angle. Okay, finding the missing angle. Okay. I'm going to have angle, angle, side, and that's the same thing. I'm going to use law of sines after finding that missing angle. Okay. Side, side, angle. Remember, if this is spelled backwards, it's a problem. And the problem, remember from law of sines, is the ambiguous case. Okay, so SSA, this is law of sines, and we're going to highlight that this is the ambiguous case. With the ambiguous case, we have to find H, okay, and determine if there's going to be no triangles, one triangle, two triangle, however many triangles, okay. So SSA is the problem spelled backwards, and it's the ambiguous problem, okay. Side, side, side is law of cosines, okay? Because law of cosines gives us 1, 2, 3 sides in the formula, and then a missing angle. So I can use law of cosines for that. If I'm given side, angle, side, okay? If I'm given side, angle, side, let's go ahead and take a look at the triangle side, angle, side. Well, I'm missing a side. And in my formula, I have side, side, and the angle in between. Side, side, and the angle in between. Side, side, and the angle in between. If I'm given that information, I can find the remaining side by using law of cosines. Okay, so I see side, angle, side. I'm using the law of cosines. There is our denotion for when we should be using law of cosines. In the next video, we'll talk about the area of a triangle as well as the Heron's formula.